Good evening, sir.
Hello, good evening, everyone.
Good evening, sir.
Good evening, sir.
Okay. Okay. So what we are discussing? So in the today lecture, we have discussed the program control instructions. Yes, are you there?
Yes, sir.
Yes. Okay. So today we will continue the today lecture. That is program control instructions. So we are explaining the conditional. Okay, conditional branch instructions. So in that we have taken an example for a conditional branch instruction. So what is that? We are performing the comparison operation. Okay. So A minus B operation. So what is the value? A value you have taken? Do you remember this? Triple one, the code that is double one, double one, double zero. And this is B equal to, what is the number? Triple zero, 101, double zero. So what is the, now see, we already discussed the signed, that is unsigned numbers. Okay. Now let us perform the signed numbers. Okay. Signed, it is a, assume that these numbers are signed numbers. That means the given number may be positive or negative. So depending upon the MSB. Now tell me if MSB is 1 in the A operand A. So what number it is? It is a negative number or positive number? Hello?
Negative number, sir.
Negative number. So we know that all the negative numbers are represented in 2's complement form. Okay. So what is the 2's complement of A? 2's complement of A. Okay. What is the 2's complement of A? You know the shortcut form. So how to write? First to write up to the first one occurs. Okay. The remaining bits are complemented. 0, 0, 0,
Complemented.
1. Okay. So 1, 2, 3, 4. So this is the 2's complement of A. Then what is the value? Decimal value. So the decimal value of this number. Okay. Now see here. 8, 4, 2, 1. So this is 16. And now do this 16, 8, 4, 2, 1. Just wait, just wait. Here it is a zeros, right? Zeros. Okay. Yes. Now what is the value? What is the value, Ra?
16.
Yes, directly 16. It is a, now what 16 it is? It is a plus 16 or a minus 16?
Plus 16.
No. It is 2's complement form. I told you when MSB is 1 means
Okay,
it is
okay.
a negative number.
Minus 16. Sir.
Yes, minus 16. So this is the decimal equivalent of our given operand A. Decimal equivalent of given operand A. Now tell me, what is the B operand? Operand B is a positive number or negative number? Operand B is a, what is operand B, Ra? Operand B is a positive number. This is a negative number.
Positive number. Positive.
Yes, because MSB is 1, it is a positive negative number A, but B operand B is a, so it is a positive number because our most significant bit MSB is 0, so it is a positive number. Now let us perform the A minus B operation. So what is A minus B? So in order to perform the A minus B, so we are writing this A minus B equal to A plus of minus B. A plus of minus B. So that is nothing but, so A plus of minus B means what? 2's complement of B. 2's complement of B we have to take. That means the ALU will not perform the addition or subtraction operation. So instead of performing subtraction operation, so it will perform the that is the addition operation only by taking the negative number as a 2's complement form. So now let us perform the A minus B operation. Now what is the value of A? So the value of A is same. Just only to know the what is the value of this. Okay, that means here you should get what? So minus 16 is the A operand, and minus B is what? B is a plus. B is a plus. What is the value of this? So tell me. So 8421, 16. Now what is the decimal equivalent? 16 plus 4. Okay, 20. So it is a plus 20. Okay, so it is a plus 20. So therefore, minus 16 minus 20. So minus 36 you should get. The answer should be minus 36 in the decimal equivalent form. Therefore, when you are performing the subtraction operation, you take the whatever the value is there in the A operand. Okay, that is a 1 1 1 1 0 0 0. Okay. Now what is the B value? So B value, take this that is the 2's complement. What is the 2's complement for this B value? What is the 2's complement for this B value? Okay. So please take that 2's complement for this B value. Okay. So the B value is now tell me, up to first occurrence is same. That is up to 100. Okay. This 100 is same. So remaining bits are complemented. Okay. 0 become 1, 0 become 1, 0 become 1, 1 become 0, 0 become 1. Okay. So this is the B value now. Now we are performing the addition operation. So I told you A minus B means A plus of minus B. So we are adding these two numbers, operand A and operand B. So this is A0 to A7 and B0 to B7. Now 0 plus 0. What is 0 plus 0? Sum 0, carry 0. 0 plus 0, sum 0, carry 0. 0 plus 1, sum 1, carry 0. 0 plus 1, sum 1, carry 0. 1 plus 0, sum 1, carry 0. 1 plus 1, sum 0, carry 1. 1 plus 1 plus 1, sum 1, carry 1. Okay, 1 plus 1 plus 1. What is the value? Sum 1, carry 1. Okay, so this is a C8. This is a C8. This carry is carry 8, carry 7, carry 6. Okay, like this we are going to have. Now this is our F0. Okay, this is our, after including this ALU, so this is the output of the ALU. Now this is the output of the ALU. Now what is the decimal equivalent of this ALU? Please check it. What is the decimal equivalent of ALU? Now tell me, MSB is what is MSB? MSB is, hello, are you there? Please respond, Ray.
1. MSB is 1.
Means it is a negative number or positive number?
Negative number.
Negative
Now please take the 2's complement of this 2's complement of this number, 2's complement of this result, the output of the ALU. 2's complement of this output of the ALU means tell me 0 0 1 0 0
0
1 0 0, right? Now see 8 4 2 1. Now this one is 16 32. Now what is the value? 32. This is a 4. What is the value? What is the value? What is the value? 34
36,
plus
sir.
2.
36.
36 of decimal equivalent. Now see here, that is called, because it is 2's complement, it is a negative number. So we got the 36 value is the right answer. Now see here. So already we taken this 36 is the, okay. minus 36 is the answer if you perform the subtraction operation of the operand A and operand B. So we got the same answer. Now tell me, now from this we should know what are the status of the CPU. The status of the CPU means the status bits. So we know that the PSW, processor status what. So now tell me, if MSB is 1, MSB we got 1, then what is the carrier? Sorry, what is the sign bit? The MSB is 1, what is sign bit? What is the sign of sign flag? What is sign flag?
One.
Sign flag is one. Sign flag is set. Sign flag is set. Very good. Now tell me. Now the total value is the total value, it is not equal to 0. It is not equal to 0. So therefore, the Z flag is 0 flag is set to
0.
Yes. 0 flag is set to 0. 0 flag is set to 1. Yes, 0 flag is set to 0. Very good. Right.
0.
Because if the result is 0, then 0 flag is set to 1. Because the result is here not 0, therefore the 0 flag is set to clear. That means 0 flag is clear, means 0. Okay. Next two. Now next one is what? What is the next condition? So next we are checking that C8, exclusive OR with C7. C8 exclusive OR with C7 indicates what? Now what is C8 value? Because carry 8 is 1, exclusive OR with 1. What is 1 exclusive OR with 1? 0. So which indicates what?
0.
What is the carry flag? What is the carry flag? Carry flag is what? 0 or 1? Hello? Sorry. It is not carry flag. It is an overflow flag.
Overflow.
Yes, we are checking the overflow flag. Yes. Okay. Now what about the overflow flag? Overflow flag is set to
1, sir.
No, there is no overflow because
0.
1 exclusive OR with 1 is 0. If this exclusive OR is set, that is 1, then only overflow flag is set. Otherwise, overflow flag is cleared. So therefore, there is no overflow because here. So minus 36 is the within the range. You know that minus of 2 to the power of n minus 1 to plus of 2 to the power of n minus 1 minus 1. The range of the register to store the value. So this minus 36, now you know this minus 128, 8-bit, minus 128 to plus 127. We know already we discussed in the first unit itself. Okay, for 8-bit register, the range of the value which can store. So minus 128 to plus 127. So this minus 36 within the range of the register. That is within the range. So therefore, there is no overflow. In the same manner, the hardware also, whatever the hardware implemented, in the computer, so which also give the 0 as the exclusive OR operation. So therefore, the overflow flag is 0. So it is clear. It is not set. Okay. Now what about the next one, What is the next one? Z, that is 0 flag. Okay. Now what is the carry flag? What is the carry flag, Because C8 is what is C8 value? C8 value
1.
is 1. Therefore, what is the carry flag?
1.
Yes, carry flag also 1 because carry flag is set. So in this way, we will know the computer, the processor will know the status of the all the flags in the computer. So depending upon the status, so it will execute all the conditional based instruction, conditional branch instruction, whatever the condition based condition based skip instructions. So therefore, there are the different instructions are there. So depending upon the status bits, so the processor, the CPU will execute all the instructions. So this is about the the program control instructions. So we have discussed the program control instructions. So program control instructions are mainly how many? So first one is a branch, call, jump, branch and jump are same, skip, call, return, and test and compare. So these all are the program control instructions. Okay, so this is about the program instruction. Now I am switching on to the next concept is program interrupt. Program interrupt. Now what is meant by a program interrupt? Okay, so program interrupt nothing but the transfer of program control from a currently running program to another service program as a result of external or internal generated request. I repeat. So what is a program control interrupt means? So transfer of the program control, that is the control is transferred to the another location, that is control transfer to the whenever the CPU is running a program, so some request is the CPU got request from some external or internal generated request. The request may be internal generated request or external generated request. So this is called a program interrupt. That means whenever the processor is executing an instruction, okay, the program is executing, the processor executing the program, it got a external internal request, so that is called an interrupt. Okay, so there are so many advantages of the interrupt. So now see, listen here, interrupt means it is looking like a disadvantage, but it is not a disadvantage. It is a advantage because whenever the priority, okay, whenever the priority, the processor has to, okay, so whenever you are giving some, you have to print the data. You want to print the data, so then the program, the process CPU will stop executing that the program, and it will come to the request to, okay, as asked by the user, and it will print the data. So print the that data. So that is called interrupt. So now this control, after executing this request, okay, after executing this interrupt request, okay, whether external interrupt or, okay, that is a internal interrupt. So the control returns to the original program after the service program is executed. So that is you need to understand here. So control returns to the original program after service program is executed. So this is what the program interrupt. So the interrupt procedure. So what is the procedure of this interrupt? So like you see here, the interrupt procedure is it is similar to the like subroutine call and return. So whenever we are executing a program, whenever the function call occurs, so the control will go to that function, it will execute that function and return to the saved address, return to the saved address. So this program interrupt is also quite similar to that is subroutine call, except to some conditions. Except to some conditions are there. So what are the conditions? The conditions means, so first one is so interrupt is usually initiated by an internal or external signal rather than from the execution of an instruction. So listen here, we already know that. So whenever some program, see here, now there is a memory. Okay, we know that there is a memory. So in the memory, there is a program is there. Okay, instruction 1. What is the program? Collect set of instructions. So instruction 3 like this. So let us say at 100 location. So and 1 at 1 location, 1 at 2 location. Now see here, whenever you executing the program counter value, let us say 101. Program counter value is 101 means the processor is executing the I2 instruction. That is instruction 2. Okay. Then there is a function call occurs. So the control will jump into this location. The control will jump into location or branch into this location. So it will execute this. Before jumping into this, though the return address 102 is saved. 102 is saved in a stack or any memory location or any register. So depending upon the internal organization of the computer. Okay. So this 102 value is stored in some other location. So and then the subroutine call is executed. Okay, and then return to the 102 location. So this is called the subroutine call and return. But what about this? Interrupt? So interrupt means so initiated by internal external signal. Okay, rather from the execution of the instruction. Actually, the subroutine call is instruction. It is also instruction. But here, okay, just wait. Small interrupt here from my side. Yes, it is a interrupt. Okay, right. Now here, so here you need to understand subroutine call is a instruction. Subroutine call is a instruction, part of the program. Whereas here, interrupt is it is not a instruction. It is a interrupt is a okay. It is generated by some internal or external that is execution of the internal or external signal. It is a internal or external signal. Okay, it is not a part of the program. Whereas subroutine call is a part of the program. Okay, that is understand. First two variation. The first variation between interrupt and the subroutine call. Okay, next what is the second one? Now see here. So in the subroutine call, okay, the subroutine call, the address part, okay, the address part of the interrupt service program is determined by the hardware. Okay, in the subroutine call, the address is okay. So in this, when you are executing this I2 instruction, okay, the subroutine call address, let us say effective address. It is we already taken that effective address. Let us say 1000. It is 1000. So this 1000 is okay, written in the program itself. Okay, that means let us say jump 1000, or you can say branch 1000 location. So like this, you are going to that means the address is in the instruction itself. But In the interruption, the address part is the address is generated by the hardware component. Okay, the address part, the address of the interrupt service program is determined by the hardware. So rather than from the address field of an instruction. So that is one of the difference between the subroutine call and the interrupt. Yes, are you following, Ra? Hello?
Yes, sir.
Yes. Okay. Now, right. Now, third point. What is third point between the, that is the difference between the interrupt and subroutine call? So here, an interrupt procedure usually stores all this information necessary to define the state of the CPU. Okay. So state of the CPU, that means whatever the state of the CPU means, like, you know, all the flags. Okay. All the flags, all the status flags, that is a PSW. Okay. Program status word. So it will store, the computer will store all this program status word rather than storing only the program counter. Now see here. So in the subroutine call, only we are storing the 102 in other location and memory location, or you know, like stack or in some register. Okay, but here it is not only storing the program counter value, so but also it is storing the all the status. Okay, all the status of the register status or something like, you know, like all the flags. Okay, that is important. That is the difference between the subroutine call and the interrupt. So the procedure of this interrupt is quite similar to the subroutine call, but it is quite something different. So first part is we already discussed that it is initiated by the internal or external signal rather than execution of the instruction. Next, second point is you to understand that so it has to the interrupt is okay. Then the interrupt, the address of the interrupt is generated by the hardware components. Okay, whereas the instruction, that is a subroutine call, is the address is there in the instruction itself. Now third point is okay, before going to the interrupt service, okay, the address not only storing the program counter value, it also store the all the information necessary information. Okay, that is all the status flags and everything in the it will store. Okay, right, this is the difference between the interrupt and the subroutine call. Now, so the status here. So the state of the CPU, you know, the state of the CPU. Okay, the CPU at the end of the execute cycle, okay, is determined. So how to determine the state of the CPU at the end of the execute cycle means, so the content of all the program counters here, the content of the program counter, next the content of the all the processor registers, like I told you just before. So the state, very, very important, the content of the certain status conditions. So what is the overflow bit, what is the all the bits. Okay, so these are the difference between subroutine call and our interrupt cycle, the interrupt, program interrupt. Okay, so the collection of all status bits conditions in the CPU, sometimes called, what is that? Program status part. We already discussed this. The today morning lecture we have discussed the program status part. So that is the overflow flag, zero flag, okay, sign flag, carry flag, some other flag, input flag, output flag. So there are some, depending upon the computer organization, the CPU organization. So we are going to have different PSW, that is the program status bar. So this PSW stored in separate hardware register and contain the status information that characterize the state of the CPU. So this PSW will tell the state of the CPU. What is the state of the CPU? Okay, this is about the program interrupt. Now, what are the different types of program interrupt? This is very easy to understand. So there are three types of interrupt. First one is external interrupts, internal interrupts. Next one is that is a software interrupt. So third one is a software interrupt. Now let us discuss one by one within a short time. Right. Now see here, external interrupt. So coming to the external interrupt. Okay. Just wait. Yes. Right. So coming to the external interrupt. So external interrupts are initiated from, okay, IO devices. Like when you are executing the program. Okay. So you want to print the data. Or you moved you interrupted with a keyboard. Okay. You interrupted with a mouse. Okay, interrupt with a mouse. That is called external interrupt initiated from IO devices. So that means the IO device may be data transfer request. Okay, data transfer, it may be data transfer request or data transfer complete. If the data transfer is completed, it is a interrupt. Okay, it is an interrupt to the processor. To the processor, it is an interrupt. Next, to timing device, like timeout. Okay, the timeout also is an interrupt. Okay, next, power failure. Example for this external interrupts are. Power failure is the example for the external interrupts. Okay, next, operator. So power failure operator. So these are the various examples for this external interrupts. So external interrupts are initiated by the external signal. Okay, external signal like IO devices, like power failures. Okay, when the data is transferring or data transfer is completed, these are the external interrupts. Okay. So next one is coming to the internal interrupts. So these internal interrupts also called as traps. Okay. These internal interrupts also called as traps. So these internal interrupts arises from illegal use of instruction or data. That means what you understand means, so if you take the example of this internal interrupt means, so see here, so whenever this internal interrupts caused by internal error, okay, internal error conditions or register overflow. So register internal interrupts means what? Whenever executing an instruction, so there is a register overflow or a stack overflow. Okay, register overflow, stack overflow. Now in your program, you are dividing a number. Let us say you are dividing a 10 by a 0. Okay, 10 by 0 means what? What is 10 by 0? It is an undefined number. Okay, it is undefined. So we cannot divide the 10 number by a 0. So dividing by a 0, it is also an internal interrupt. It is also an internal interrupt. Next to opcode violation. So you are not writing, instead of writing the addition, you are writing here like this AD. It is a opcode violation. So opcode also, if you don't write the program in a correct manner, so that is an interrupt. Okay. So like errors are like errors. Okay, syntax error. You may gone through. You may come across that. Okay. Next, production violation. So these all are the example for the internal interrupts. Okay. So next last one is now tell me, now let us discuss what is the difference between the internal interrupts and external interrupts. Okay, internal interrupts and external interrupts. So it is that the internal interrupts are initiated by some exceptional conditions caused by the program itself. See, whenever you are writing a program, you have done some mistakes. You are writing opcode something wrong, or you are dividing the something number by 0. So this is called it is a like a condition caused by program itself. In the program is wrong. Program itself is wrong. Okay, program itself is wrong. So that is called your internal interrupt. Okay, so rather than by external event. Okay, internal interrupts are asynchronous. Internal interrupts are asynchronous. Okay, with the program, while the external interrupts are asynchronous. So sorry, internal interrupts are synchronous. That means so if you execute the program, you get the interrupt. Okay, that means error means something interrupt. You re-execute the instruction, that is rerun the program, then also you will get the same interrupt. If you rerun the program, then also you will get the same interrupt. So that is therefore the internal interrupt is a synchronous type. The internal interrupts are synchronous type, whereas the external interrupts are asynchronous type. Okay, external interrupt. See, if you are executing the program, you may get the interrupt. In the next time you are rerunning the program, you may not get the interrupt. So that is called asynchronous type. Okay, that is called asynchronous type. So please understand that internal interrupts are synchronous type, external interrupts are asynchronous type. So see here, if the program is rerun, so the internal interrupts will occur in the same place each time. So that is called internal interrupts. Okay, so external interrupts are depend upon the external conditions that are independent of the program being executed at the time. Okay, that is being executed. Now if you rerun the program, so the internal interrupt occurs, that is called synchronous. It is a synchronous type. Okay, but external interrupts may not be occur or may occur. So asynchronous type. So this is a difference between the internal interrupts and the external interrupts. Okay, next last one is a software interrupts. Okay, time is running out. Okay, last one is a software interrupts. Yes, are you there? Hello, everyone?
Yes, sir.
Yes, only 23 members. Only 23 members are there in the class. Okay, right. Now next two. So software interrupts, so both external and internal interrupts are initiated by the computer hardware. Okay, both internal and external interrupts are initiated by the computer hardware. But here software interrupts are initiated by the executing an instruction. So how to understand the software interrupt means? So the software interrupt is a special call instruction that behaves like an interrupt rather than it is a subroutine call. So can you give the example for this software interrupt means a supervisor call. What is supervisor call means? So you are switching from the user mode to the supervisor mode. So when you turn on your computer, there is modes are there. Okay, like administration mode, supervisor mode. Okay, like user mode. Okay, you are switching from this user mode to the supervisor mode means it is a software interrupt. Next to see you when this supervisor mode, so it is allows to execute a certain class of operations which are not allowed in user mode. That means in the supervisor mode only all the instructions are executed, but in the user mode not allowed. Some instructions are not allowed. So this is called the software interrupts. Okay, so this software interrupt, it can be used by the programmer to initiate an interrupt procedure, okay, at any desired point in the program, So this is called the software interrupts. Now last topic is last slide is interrupt procedure. Okay, so just now I discussed the interrupt procedure is similar to the subroutine call, but quite it is something like different. So we already discussed. So let me quickly explain this interrupt procedure and subroutine call. So the first, the interrupt is usually initiated by internal or external signal rather than program execution. Subroutine call or program execution. Whereas this interrupt means initiated by the internal or external signal. So that you understand. So the address of the interrupt service program is determined by the hardware, whereas this whereas the subroutine call address is determined by the program itself, the instruction itself. In the address field, in the address field, let us say BR1000. Okay, it is a branch to that subroutine call. Okay, it is branch to the location. So that is called in the instruction itself address is determined. So this is the interrupt procedure. Next another point is interrupt procedure usually stores all the information. Already discussed this. Whereas subroutine call, we are storing the only the return address. We are storing the only return address, that is in the program counter value. Return address we are storing, but in the internal, that is interrupt, so we are storing all the necessary information along the state of the state of the CPU. Okay, that PSW, all the register content. Okay, that program counter value, all we are storing, rather than only CPU, only program counter. Okay, now the state of the CPU is determined. So that is the content of the program counter, all the data, content of all the flags is already discussed. So many ways to saving the CPU statements, depending upon the CPU architecture. So depending upon the CPU architecture, so we are going to save the all the necessary data. So already discussed this how to get this overflow flag, jet flag. So hardware, we know that the hardware we have used. So there is a ALU, we have used some exclusive OR operation. Okay, exclusive OR operation. Okay, so we have performed this exclusive OR operation. So we already discussed this. So the bit may be 0 or 1, like that we are going to check. So therefore we are going to understand this is the hardware required, so to know the different status of the CPU. Okay, so this is the today lecture, the program interrupt. Okay, different types of interrupts. Okay, and example for the conditional branch instructions. Yes, are you clear, Ra? Hello?
Yes, sir.
Yes.
Yes,
Okay.
sir.
Yes. So I'm revising short revision here. So, okay. So first we have discussed this example of this comparison of two operands, A minus B. So we have taken the A. It is a we have taken the signed numbers. So that unsigned number means by default it is a positive number. Okay. But signed numbers means so you need to take if the number is negative, MSB is 1, that is the number is negative, then you have to take the 2's complement form of the number. That you have to remember very clearly. Then only you can give the example in the exam. Okay. Otherwise, if you already morning I explained with the same example, but that example you got what is the A value? You got A value is 240. Yes, 240. B value is 20. So that you got that you got 220 is the answer. Okay, because that is the unsigned number. But the same values you have calculated, you got the what? See, this is 20 only because it is a positive number. The B operand is 20 only. But here the A operand is a negative number. It is a minus 16. Therefore, we are getting the minus 36 is the answer here. So that is the difference between the signed numbers and unsigned numbers. Okay. In the next third unit also we are going to have this signed numbers, unsigned numbers, floating point, fixed point representations. Okay. We will discuss very clearly. Okay. So this is what you have to take the 2's complement of this negative number, and then the ALU will not perform the addition operation. So it will take the 2's complement of the number, negative number. Therefore, it perform the addition operation instead of performing the subtraction. So we have performed this. So if this is F0 to F7, F0 to F7, okay. So A0 to A7, A0 to A7 value, okay. B0 to B7 value, B0 to B7 value. So depending upon this state bits, so we are going to have this whatever the that is a sign bit, okay, sign flag, zero flag, carry flag, okay, overflow flag, like that. We have know what is the status of the CPU, okay, right. Next, we have discussed the interrupts. So program interrupts. So program interrupt is quite similar to the subroutine call. Please speak out. Program interrupt is similar to the. Okay, I will call summarization report. I will take. Who will come here? Who is 33 ra? 33 over?
Nitin Reddy, sir.
Nitin Reddy, are you there? Nitin Reddy. He is not listening in the class. Joined and simply left. Huh? Total how many members came?
Total 23, sir. Ippudunnadi 18.
Okay, already they left, I think. Okay. Who is 61? 61.
Sir,
Can you please summarize today's lecture?
so first we discussed about unsigned numbers and signed integers with the help of 2's complement.
Okay.
And next we discussed about program interrupt, that is the transfer of program control from currently running program to another service program,
Very good.
to in the form of a result of an external internal generated request.
Okay.
And the interrupt is usually initiated by an internal or external signal,
Very good.
rather from the execution of instruction. And the interrupt usually stores all information which is necessary to define the state of the CPU, rather than storing in the program counter. And we learned about types of interrupts. Those are
Okay.
external interrupts, internal interrupts,
Okay.
and external interrupts, internal interrupts, and external interrupts are of 3 types: timing device, power failure, and operator. And internal interrupts arise from the illegal use of an instruction of data. And types of interrupts.
That is not types, Nana, that is example. Examples of external
Examples of types of interrupts are register, stack overflow, and which divides by 0, opcode violation, and protection violation. And we learned about the difference between internal and external interrupts.
Okay.
Internal interrupts are synchronous, and external interrupts are asynchronous. Internal interrupts occurs in same place at each time, and external interrupts are dependent on external conditions which are independent of the program.
Okay.
And we learned about interrupt procedure and subroutine call. Interrupt is usuated by internal or external signal, and the state of the CPU will be determined according to the content of program counter, content of processor registers, and content of the status bits. And the address of the